Hey everybody, welcome to Dome to Home. Hope you're all doing well this lovely Tuesday afternoon. We're gonna wait just a minute or two for some folks to get online, maybe refresh their browsers so everybody can see what's going on. In the meantime, we brought you some asteroid and comet jokes. You wanna hear some? Okay.
Take it away, Tara.
Huh?
Take it away.
What did the black hole say after it ate the asteroid? He said, "It was pretty good, but I wish it was a little meatier."
So are black holes vegetarians or no? I guess they would not be vegetarians. All right, that's a good one. I'll bring you guys a comet joke when we're waiting. Let's think here. What do planets like to read? Any
What
guesses?
is it?
See if there's anybody on the stream. Go ahead and comment if you have any guesses for that one. What do planets like to read? Maybe our question master Rami has a guess behind the scenes. Maybe not. We'll go for it. Comet books. So there you go. You got two bad jokes to start off your afternoon with.
Yeah. Fun fact, Jeremy's dog is named Comet too.
Yes, that's true. So if anybody hears any barking during this, it's because he probably thinks that this is a show dedicated to him.
Well, it is a show dedicated to comets and asteroids. And I think we can go ahead and get started here because we got so much cool stuff to talk about. I love comets and asteroids. It's kind of my thing. So I'm very excited to bring this to you. By the way, my name is Tara. I'm a presenter here at Fiske Planetarium. I'm a planetary scientist and a CU alum. And I've got Jeremy here with me as well.
Yeah, hello everybody. My name is Jeremy. I work at Fiske Planetarium as a navigator and an outreach presenter. And I am also a CU alumni.
So, like I said, today we are going to talk about comets and asteroids. Particularly, it said killer comets and asteroids. It's kind of a misnomer. Not all asteroids and comets are killers. Some of them are. They're all killer in the sense that they're rad and they're awesome. But I thought we'd start off by talking a little bit about what the differences are between comets and asteroids, because there are differences. They're not the same thing. Now, the first thing that makes them different is what they're made out of. So we can start with asteroids. Jeremy just put up a ton of cool asteroid pictures for you. So asteroids are generally mostly made out of rocks and metal. Some dust, you can see there, they look kind of like little rubble piles. A lot of them, some of them are. Some of them are big chunks of rock and metal, but some of them are just little collections of dust and tiny rocks and pebbles that have kind of gravitationally stuck together and they're not really cohesive. So asteroids are crazy like that. You got a lot of great examples there. Now, comets, on the other hand, are mostly made out of ice and dust. So sometimes you hear them called slush balls, dirty snowballs, things like that. So they're mostly made out of ice and they have a little bit different makeup. Like you can see here, there's sort of the anatomy of a comet. The icy slushy part is what we call the nucleus, which you can see on your screen here. By the way, if you're having trouble seeing what's on the dome, try maximizing your screen, making it full screen view. You might get a better look there. So you can see that nucleus of the comet is the snowball part. But because it's made out of ice, when it gets close to the sun, that ice heats up and starts to not even melt, but it sublimates. It goes straight from solid to gas. It skips that melted phase entirely because there's a lot of, there's no air in space and there's not enough heat for it to stay melted. It gets complicated. But that's why you see these tails. It's got two different tails on the comet. One is the dust tail from all the dirt in that snowball, kind of flies off one direction, and then the water vapor kind of falls off in a different direction. So as you see, there's a great animation there. You can see the comet moving through the sky and that tail kind of coming off behind it. Now, it's not just what they're made out of that makes them different. We also find them in different locations. And for this, we're actually going to leave the Earth here and go take a look at our solar system from out in space, because it's a little easier to see from out there. So everybody hang on.
Try to fly us there safely and smoothly, best I can.
We appreciate that.
All right, here we have our big blue Earth rising up below us. I'll go ahead and get us zooming out of our solar system a little bit. I'm gonna orient us in a way so that we're gonna be looking top down. I'm bringing up all the orbits of our planets in our solar system.
Now notice how we're looking at the solar system kind of edge on and all the planets kind of line up in that flat disk like that. It's going to be important here in a minute, so remember that. Now we're pulling out, you can see all the different orbits. Of course, the blue one is Earth, the red one is Mars, and we can go out from there, Jupiter, Saturn, Uranus, and Neptune. Now, most of our asteroids are found in the asteroid belt. Makes sense, right? This is a ring of asteroids that's between Mars and Jupiter. So Jeremy just put them up. You can see all that bright stuff right there. Those are all little individual dots showing all of the asteroids. There's tons of them in there, tons and tons and tons of asteroids. But it's not like Star Wars. So don't think that they're always smashing into each other and exploding and, it'd be really hard to get through. They're actually, even though there's that many of them, they're really far apart. The average distance between asteroids in the asteroid belt is about 600,000 miles. So very little chance that you're actually going to run into one or that they'll run into each other. We don't actually see it very often. But you can see there's a ton there. There's also a couple special categories of asteroids called Trojans and Centaurs that we see around the orbits of Jupiter and Saturn. You can see them, they just showed up kind of on that yellow line there. Those are our Trojans and Centaurs, and they kind of orbit around as well. Now, comets, on the other hand, we don't see really in the inner solar system so much. That's not where they live because it's too close to the sun. Like we saw a second ago, when the comet gets close to the sun and starts to warm up, a lot of its material kind of sublimates away and it gets lost. So these comets have to live in the far outer solar system where it's a lot colder and that ice can exist in kind of a stable form. So if we zoom out even farther here, there's something outside the orbit of Neptune called the Kuiper belt. Now, like the asteroid belt, this is a huge ring that goes all the way around the outside there, but it's made out of comets instead of just asteroids. So these are all of the ice balls and the slush balls are orbiting way, way out in the very far reaches of the solar system. You see, we got some orbits of spacecraft on there too. These are some spacecraft that have gone all the way outside of our solar system. There's the two Voyagers, Pioneer, and New Horizons, which is still going. All of these are still going. So there's our Kuiper belt. There's even some stuff even farther out, something called the Oort cloud, which is like more of a spherical kind of shell of material, thousands and thousands of miles from the solar system. So there's tons and tons out there.
Yeah, I'll go ahead and bring up these orbit lines for all of the Kuiper belt objects that we have identified. So these are all the objects out in that, like that belt, like what Tara was saying there.
Yeah, and so you can see how the asteroids and most of the solar system objects, they all orbited in that flat disk, but these comets do not. They've got some weird orbits. They come in from all different directions. You see some of them are kind of tilted. Some of them are very tilted. Now this is important, especially for comets. One of the things that comets and asteroids both do is interact with the Earth. We have some interactions with these things. Comets in particular, maybe counterintuitively, are what make meteor showers. It's not asteroids that make meteor showers, it's actually comets. Because when a comet comes in close to the sun, like we saw, it has that tail of dust and gas that gets blown off. Well, all of that material, all the gas and dust, pretty much stays where it gets dropped. So that comet's not just shooting off material into space and then it kind of dissipates. It actually is kind of leaving a trail behind it of all of this gunk. Now, if it goes through the Earth's orbit, kind of where we would pass through it, as the Earth goes around the sun, it'll move through that leftover gas and dust. And that's what we see as meteor showers. That's why they're so regular and predictable, because those clumps of material are always in the same place in space. So as we move through them, that's what we're seeing. So that's pretty cool. Now, we know that meteors also, asteroids also interact with the Earth. That's one question that I get a lot, is what's the difference between an asteroid, a meteor, and a meteorite? It's very simple. It's an asteroid when it's out in space. As soon as it hits Earth atmosphere, it's a meteor. When it hits the ground, it's a meteorite. So all meteorites are meteors and asteroids. All meteors, though, are not meteorites. Not everything that hits our atmosphere makes it all the way to the ground. It takes something really, really big and really, really coherent to make it all the way down to the surface. If it's a little thing, it might burn up in the atmosphere, or it might break into lots of smaller pieces. It's really hard to get through an atmosphere. So that's kind of how we end up with these meteors and meteorites. I've got a picture right back behind me of Meteor Crater in Arizona. It's a kilometer-wide crater, one of the best preserved craters on Earth. Jeremy's putting up some more dots here for us.
Yeah, I'm just currently flying us back into the home so we can take a look closer at our own Earth here.
Perfect. So while he's flying around, I did bring a couple of examples of meteorites that we have here at Fiske. See if you can see these ones. It might be a little tricky, but this one is my favorite. This is just a slice of a meteorite, of a much, much bigger piece. But you can kind of see here how it's very shiny because it's made out of metal. This one is mostly iron and nickel. That's a really popular thing that we find in meteorites. It's a lot of iron and nickel, so it's really heavy. It may not look like it because it's so thin, but it's actually very heavy. So lots of our meteors are made out of metal like this. But we have some other ones that are rocky, like this little guy. He's kind of hard to see. This one's much more rock. It doesn't have that metallicness to it, just rocky. But I wish you guys were here, because if you smell it, it smells burnt. So you can tell that it came through our atmosphere and was probably on fire at some point before it hit the ground. So I like these ones because you can tell that it came through and was very, very hot. And that's just a couple. We've got another one here that's pretty rocky. So they're not all super metallic, but a lot of them are. And that allows them to penetrate through our atmosphere so they can make it all the way to the ground. Now we're being pretty much constantly bombarded by little tiny meteors. So lots of little stuff is hitting our atmosphere all the time. Not always big things, but we do get hit by some pretty large meteors at times. Now this map that Jeremy just put up here, the bolide events, those are things that hit our atmosphere that didn't make it to the ground. So you can see there's a ton of them. Lots and lots of stuff, and that's for just a 9-year period. And the influx of these comets or asteroids that are hitting our atmosphere is pretty constant. So we expect to see about that many for that period of time, just kind of continuously. But we can also show you a map of where we have seen some really big impacts here on the Earth. Jeremy put up our little circles here.
There we go. So yeah, circled in red now. Oh, we're upside down, it looks like, but as I orient us right side up, yeah, those red circles are going to be locations of impacts on the surface. There we go.
Really, if you want to get technical, there's no up and down in space.
Exactly.
So really, we're always upside down or right side up, depending on how you want to look at it.
zoom in a little bit more so you guys can see some of these. We're gonna get up close and personal with the Earth here.
Yep, there's a little one down in the desert there, I see.
It'll become a little bit more obvious too once we get to the night side here.
You can see a couple of big ones in Russia. Russia has a couple of very famous meteor impacts. There's some more big ones around Greenland. There's some big ones in Canada. Like I said, there's Meteor Crater here in Arizona that you can visit. Now, a lot of the impact sites that we have here on Earth are really hard to find because we also have things like wind and rain and snow and things that can erode those craters. It can kind of wash it away. So really, really old impact sites, like the one that killed all the dinosaurs, it's really hard to find because it's been covered over or filled in or buried. So a lot of these impacts are really hard to find, and Earth probably has been hit by a lot more things than we can actually find. Now, that's one of the things that makes asteroids and comets so cool, is that they can tell us a lot of things about the thing that they hit. Now, this is one of the things that we like to do to study planets and bodies that are not on the Earth, things that are really hard for us to get to. We can look at the craters and the things that hit it and learn a lot about them. Probably the easiest and most famous example is the moon. So the moon, you've probably noticed, has a lot of craters. Not so much on the one side, the side that we see all the time where the dark stuff is. Those dark things aren't necessarily craters. Some of them are, some of them aren't. But like that big bright one down on the bottom left, you can see that's a huge impact there. Now the other side, the far side of the moon, has a lot more craters because it didn't have anything on that side that can erode them away. On the side that faces us, there was a lot of volcanic activity that could fill in those craters or wash it away. They didn't have that on the far side for some reason. And here I've got a topographic map so you can see where all these impacts have happened. Some of them are much, much deeper than the material around them. And you can probably imagine when a big rock comes through space and hits the moon, it's going to dig up a bunch of stuff. That material doesn't get smushed down, it gets thrown out. And everything that gets thrown out and makes that big crater, some of it lands back on the surface, but some of it doesn't. Some of it can be ejected all the way back into space. And it might orbit around the moon for a little longer and then fall back down, or it might get caught in Earth's gravity and get brought down to Earth. We see this a lot with asteroids from the moon and also from Mars. Things that get kicked up off of Mars, a lot of times can end up back on the Earth. And so that's one way that we can learn about the moon and Mars without actually going there. We find these meteorites, we can tell where they came from, and we can get an idea of kind of what the surface of this body is like, the planet or the moon or whatever it is. Now, these can also tell us a lot about the early days of our solar system. Because these asteroids, a lot of times, are leftovers, basically, from planetary formation. Way back at the very beginning of the solar system, there weren't just automatically planets going around. They didn't just kind of migrate in from elsewhere. Everything started as a big disk of gas and dust that was all orbiting around our star. Stars are really big. They have a ton of gravity. They draw a lot of stuff in. But as time goes on, all of these little gas and dust particles kind of bump into each other and stick together. And they have a little more gravity that way. And as they get bigger, they have more gravity, draw more things in, get bigger and bigger and bigger. And this is how planets grow. But not everything gets sucked up into a planet. You can see here, these are some pictures from the ALMA telescope of what we call protoplanetary disks. These are areas where planets are forming around stars. These are stars far away from us. This is not our sun. We don't know what it's like at the beginning of our solar system, but we can see other solar systems forming. And so you can see how they kind of, the little planets that are forming clear out a little path in all that gas and dust. You can see the kind of empty space. But there's all that other stuff too on the outside. So that is what ends up a lot of times forming the asteroids that we find in our inner solar system. They're just leftovers from things that didn't quite make it into a planet. So we see these all over the place. And that tells, by studying these asteroids, we can learn a little bit more about what conditions were like at the very, very early times in our solar system. We can see what things are made out of, how many of them are, how big they are, things like that. Now we've even just now, the last couple of years, have found interstellar comets and asteroids that are coming from places outside of our solar system. And not just the Oort cloud, far, far outside from whole other star systems, we think. There was one called Oumuamua. It's a funny name. It's a Hawaiian name. This was the first one that we ever found. It came shooting in from far, far away, made a quick lap around the sun, and then blasted back out. And we just had just enough time to take a couple of pictures and a couple of measurements and learn a little bit about it. There's also been oh, sorry, go ahead.
Yeah, if I could just inject real quick, what you're seeing in these pictures here, on the right is an artist representation because it is a pretty small object and it's a very dark object. So we didn't actually get any direct imaging, visual images of it. But on the left is a picture of like kind of a locator of it. And then you can see that the small circle. It might be tough for you guys to see unless you guys go into full screen mode. But you see these trails are actually the star trails coming by it, and then at the center is this interstellar interloper object.
Excellent. So that's our interstellar asteroid. And then we have an interstellar comet as well that we just discovered called Borisov. And it's the same kind of scenario. It came in really fast from far, far away, lapped around the sun, and then shot right back out. But we did get a couple of pictures of that one too. Here you can see up at the top shows you the trajectory that it took coming in and flying out really fast.
Yeah, so
that's just
pretty...
a little about, oops, sorry, go ahead.
Sorry. Yeah, no, it's pretty crazy. I mean, being able to actually identify something that has come from a solar system other than our own. And I'm sure now that, we're kind of looking for these more actively, I'm sure we might be able to start finding and categorizing many more of these in the years to come.
And I think that is a fabulous way to wrap up our comets and asteroids talk because we were just running out of time, but I did want to have some time for questions at the end in case you thought of any. I see that Denise already had one. Why is the asteroid belt where it is, and why is it not a planet? That is an excellent question. So we're not 100% sure, but our idea right now is that it's right in between the orbits of Mars and Jupiter, right? So Jupiter is the biggest planet in our solar system. It is massive. It has a ton of gravity. Mars, on the other hand, is very small. It's about half the size of the Earth. But if you combine Mars and Earth and Venus and Mercury and all the inner solar system stuff, there's a lot of gravity there too. And so the interactions between the gravity of the inner solar system and then the gravity mostly of Jupiter, but the other outer solar system objects as well, is just kind of in this perfect kind of mode to where these objects are being pulled around too much by the different gravity and they never really got to cohesively stick together. So it's that gravity that keeps them in that, really narrow belt where it is, but it's also what keeps them from forming a planet. That's an excellent question. One we're still kind of dealing with. Nobody really knows for sure, but that's our best guess so far. Anybody else? Now, I will mention that we're getting to learn a lot more about comets and asteroids with missions. We've now been able to land spacecraft on comets and asteroids. This is a very exciting thing, not just NASA, but space agencies around the world. Currently, upcoming, there are 15 missions to study asteroids and 14 to study comets. So we're focusing on things like sample return, where we bring back pieces of the asteroid back here to Earth. There's also a lot of people learning about what we call asteroid deflection. What happens if an asteroid's coming at us? Could we maybe knock it off course? Which is a pretty exciting idea. Here we go. How do we know that these two asteroids and comets were from outside the solar system? Another excellent question. And it comes back to the trajectory of them. So we didn't get to see them too much because they were moving so quickly, but we can tell which direction they came from and which direction they left out of, and use some kind of tricky math to figure out where they came from, how far away they might have come from, based on how fast they were going and how they came into our solar system. Even the asteroids that come from the comets that come from the Kuiper belt, we saw they had those really crazy orbits. They're usually not quite this crazy. You see how these ones kind of came in almost vertically. So we don't really see that with these comets in our solar system or even just outside of our solar system. There's still, there's some variation, but it's not quite this much. So by looking at how they came in and how fast they came in, we can kind of backtrack and figure that they didn't come from anywhere near here, which is pretty cool. Well, if we don't have any more questions, I will go ahead and throw out a couple of announcements too. There is a meteor shower coming up in a couple of weeks, the Perseid meteor shower. It's going to be active from July 17th till August 26th. But if you come back and check out Dome to Home on August 4th, we are going to be talking all about this meteor shower and how you can see it. So that's probably a good one to check out. I would also recommend Fiske's podcast for this week. It's called A View from Earth, launches every Thursday. And this week in particular, we are talking about asteroids and comets. We've got an interview with Dr. Daniel Shiras, who's an asteroid expert. He also has an asteroid named after him. How cool is that? And we're interviewing 𝐀𝐜𝐭𝐢𝐯𝐢𝐭𝐢𝐞 here at CU, who works on an asteroid deflection mission. So she's all about planetary defense and planetary protection, has some really cool stuff to tell us. So definitely check that out too. Otherwise, don't forget to come back next week too. Same time, same channel. We'll be here at 2 o'clock next Tuesday talking about Mars 2020, the newest mission to Mars, and what kind of things we're going to learn from that. So it's going to be a really good time. So from here at Fiske, my name is Tara. Thank you again. Thank you to Jeremy for flying us around today.
Yeah, thanks for joining us, everybody.
All right, and we will see you next week.
Bye.